I'm Anil Kumar sharing with you one of the most important questions on permutations and organized counting. In this particular video, we'll discuss a couple of examples where we look into permutation of R items with several identical sets. Questions here are very similar and we'll actually follow one strategy to solve them. Question number 1 is, how many three-letter words can be made from the letters in success? Then we have question number 2, which is also how many three-letter words can be made from the letters in settlements. Question number 3 and 4, in them we'll find how many five-letter words can be made from the given word. So I'll actually solve first, second, maybe third, and then leave one for you to practice and understand the technique. Now in such cases, we will do organized counting and permutation combination. So we are considering cases to solve such questions. So let's see how to find their answer. The very first question here is, how many three-letter words can be made from the letters in success? So let's try to understand the word itself. We have letters as C-U, C-C, E, S-S. So in all, how many letters do we have? We have 1, 2, 3, 4, 5, 6, 7 letters. What do we need? We need to place them in a way so that we can fill in 3 spaces, just 3 spaces, not all 7. Now amongst these letters, how many of each kind do we have? So as far as S is concerned, so we have got 3 S's, okay. Then 2 C's, 2 C's. And then we have single letter U and single letter E. So one number of U and one number of E. So let's count 1, 2, 3, 4, 5, 6, 7. So these are all 7 letters. Now since you can see some letters can come twice, some can even come 3 times. So in this case, we should actually go with cases. So let's see how to organize our cases. So let's say case 1. Here we'll take only single letters, no repetition. When I say only single letters, that means we will be working with only one S, only one C, only one U, and one E. You get the idea, right? So we are working only with 4 letters and we have to fill in 5 spaces. Nothing is repeated. So how many ways can you do it? Well, we are doing 4. Out of 4, we are selecting 3. So 4P3 is the answer, correct? So that is case 1. Now let's do case 2. In case 2, we will take one double. That means one letter will be repeated, right? So only one double, right? One double only. Let me write like this. So in that case, we have 2 possibilities. We could have 2 C's along with any of the others, which are S, U, and E, right? Or we could have 2S with C, U, or E, correct? So that becomes next combination. Okay, so let's look into this one first. So again, we are left with 3 spaces. So we are going to fill these 3 spaces with 2 C's first. Now, how many ways can we do that? Well, 2 C's means there's a repetition, but we are filling these spaces and total number of letters, total number of places are 3, 2 C's to be filled. So that becomes 3P2, correct? 3P2. two C's can be filled in. Now, once you fill in two C's, then one of these three can get into. So those are three different ways. So I'll multiply that by 3. And now we could have double with S also. So times 2. Does it make sense to you? Correct? So you get the idea. First we'll fill up these two C's. We have 2p2. Now I forgot to write divided by 2 factorial, since they are not a C here and C there and their reverse will just give me one combination. So we have to divide by 2 factorial. Got it, right? Then 3 of these letters can come one by one, so times 3. So we get with 2 C's. Now same story is to be repeated with 2S. So that's what you get. Is it okay? Now let's talk about case 3. So in case 3 we have triple. Because we cannot have two doubles, right? We are only limited with 3 positions, so we can have a triple. Triple combination is only 1, right? So which is only 1 for us. Is it okay? Now combining all, we get our final answer, right? So we can combine all this. So we get our answer as total of all this, which is 4p3 plus 3p2 divided by 2 factorial times 3 times 2 plus 1. You get an idea, right? Let's calculate and write down the answer. So we have 4p3, which is 24, plus 3p2 equals to, so 2 factorial and 2 factorial gets cancelled. We'll just multiply 6 by 3. We get 18 here and plus 1, and that gives you 24 plus 18 plus 1 as 43. So there are 43 different ways in which we can make 3-letter words from all these letters in success. Now let's take another example. How many 3-letter words can be made from the letters in settlements? I'd like you to pause the video, answer this question, and then check with my solution. So let's write down the word. It is settlements. S-E-T-T-L-E-M-E-N-T-S, right? So how many letters do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now let's write down how many of each kind. So S, 1, 2. So as far as 2 is concerned, we have 2 S's. E, 1, 2, 3. So 3 E's. T, 1, 2, 3. 3 T's. L, L is single. So let me write 1, L. Okay, M, just single. N. Okay, so we have taken care of all these letters. It's good to write like this. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have taken care of all 11, correct? We want 3-letter words, only 3-letter words, right? So 3-letter words. 3 spaces to be filled. We'll again go with our options. Case 1. Case 1 is single, right? So we'll say single. No repetition, no doubles, no triples. So single means, what are we considering? We are definitely considering L, M, N, 1S, 1E, and 1T. So we have 1, 2, 3, 4, 5, 6, and we want to fill in 3 spaces. All are single, right? So 6P3. It makes sense, correct? Now let's do case 2. Case 2 means 1 double. Okay. Again, what combination could we take? Well, let's take 2S first, right? So let's do with 2 S's. That is 1 double I'm taking, right? And the others are all single, which is L, M, N, E, and T. So we are left with 1, 2, 3, 4, 5, 6, 7, right? And we have to fill in 3 spaces. So 7 fill 3 spaces, but we have one double, right? So we have one double means 2 factorial. Does make sense? Perfect, correct? So 7, 1, 2, 3, 4, 5, 6, 7 fill 3 spaces, and we have a double. So divide by 2 factorial. Now this could have been replaced with 2 e's and 2 t's. So we could have 2 e's, or we could also have 2 t's, right? So that means times 3. So with one double, we get all these combinations. Okay, let's do case 3 now. Now in case 3, we could have 2 doubles, because no, we cannot, because there are only 3 spaces. We are working with 3 letters. Yeah, okay. So we have covered doubles. How about triples now? So we say 1 triple. 1 triple means I could have either 3 e's or we could have 3 t's. Is that okay? All. So if we do that combination, what are the other things we have? We have 1 s, l, m, and n, right? So that's what we have with both, right? And also a t here, and in this case we'll get e. Perfect. Correct. So how many letters are we working with? 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 p3, out of which we have a triple, so divide by 3 factorial, and we have 2 such things. We could go with t's also, right? Times 2. Does it make sense to you? So those are the total number of options which could help us find the answer for the given situation. Do you see that? So we can just combine them. So total for us is 6p3 plus 7p3 2 factorial times 3 plus 8p3 over 3 factorial times 2. So I hope I have considered all the cases. Let's calculate. 6p3 is equals to 120 plus 7p3 will multiply by 3 and divide by 2. Okay, so 315. Then we have 8p3. Okay, so 8p3 we have to do times 2 divided by 3 factorial, right? 3 factorial is 6. So we'll do times 2 and divide by 6. 112 plus 112, right? Let's add them all. So we have 112 plus 315 plus 120, right? 547. So hopefully the calculations are correct. You can always check the calculations. I hope the method is clear to you, right? So that is how you have to do. Perfect. Have a good look. We'll take up another example, and now we'll consider 5 letters. Okay. So this is actually question number 2. I just changed the order. How many 5-letter words can be made from the letters in fulfillment? Same exercise. So let's rewrite. So we have fulfillment. F-U-L-F-I-L-L-M-E-N-T. Let's count the words. Letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 11. How many of each kind? So let's say F. 1, 2. So we have 2 F's, right? 2 F's. U. 1. So just 1. So 1 U. L. 1, 2, 3. So 3 L's. I. Just 1. Okay. And M. 1. E. 1. N and T also 1, right? So N and T. Okay, let's recount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Perfect. Now we are looking for 5 letter words, right? So we are looking for 5 letters word. Okay. 1, 2, 3, 4, 5. How many cases can we work on? Well, case 1, single. So actually it's a good method. So I hope you appreciate it. So we'll just say single. So if I'm considering single, what are the letters we are considering? So we consider 1, 2, 3, 4, 5, 6, all these. U, I, M, E, N, T, F, and L. Is that okay? So that is all. So we have 1, 2, 3, 4, 5, 6, 7, 8. We want to fill up 5 positions. 5 positions. 8, P5. Perfect. Case 2. Case 2 is 1 double. Okay. 1 double, so that means we could have 2 Fs, right? So in that case, let me write all these numbers as said. U, I, M, E, N, T. And first we'll take 2 Fs. So we'll take L here and 2 Fs. Perfect. That means 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 P5. Since we have 1 double, we'll divide by 2 factorial. Now, we could make this double combination with 2 L's also, right? So we could also have here like 2 L's and a F, and this remains same, right? Perfect. So that means I should multiply this by 2. Correct? So that is with doubles. Now we could have a case 3 where we could have 2 doubles. So 2 doubles means we have these letters which are U, I, M, E, N, T. We have 2 F's and 2 L's. Correct? So we have 2 doubles. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 are total number of combinations. I mean, out of 10, we have to select 5 positions and we have 2 doubles. That means divide by 2 factorial, 2 factorial. Is that clear? So that becomes another case. And the last case here will be, let me write here, case 4. Case 4 is having a triple. So if I have a triple, that means I have L, right? And with this triple, I could have all these numbers. So just a triple, no doubles we're talking about. So let me see what letters we're talking about. Triple means L, L, L. So we have all of the single. So F, U, I, M, E, N, T. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So out of 10, we have to fill in 5 positions. 1 triple means divide by 3 factorial. Now we could also have a case 5, which is triple and a double. Is that correct? So that makes only combination of 2 F's and 3 L's, triple and a double, right? So that gives me triple and a double means we have 5P5, right? I mean 5P5 divided by 2 factorial times 3 factorial. Is that clear? So these are all the combinations which are possible. Now let's write down the total. So total in our case is 8P5 plus 9P5. So I'm cancelling these two, okay? And then I'm writing plus 10P5 over 2 times 2, I'm writing 4. And then we'll add 10P5 over 3 factorial, which is 6. And then we have here 5P5 over 2 times 6, 12. Let's add them, get our answer. Is it okay? So 8P5 plus 9P5 plus 10P5, so we'll put them in brackets this time, 10p5 divided by 4 bracket close plus 10p5 divided by 6, 10p5 divided by 6 bracket close. Okay, so I didn't put a bracket there. It was not required, but just to be on safe side. Okay. And the last one is 5p5 bracket divided by 12. So we'll do plus 5p5 divided by 12 equals to. So we get a number which is 34450. So I'm not really checking my calculations now. You could do these calculations, add them up, and probably you will come up with the same result. If not, just tell me what is the right answer. Perfect. So that is how we could do it. Now the last question, which was how many 5-letter words can be made from the letters of successes, I'm leaving for you to do. So I hope that helps. So you could actually solve such questions using different types of cases. Then it becomes simpler. Thanks for watching. And if you like and subscribe my videos, that'd be great. Thank you and all the best.